Okay, hey everyone, I'm Dhvani. This is Mann, Curtis, Eric, and Tyler, and we're Team Nautilus. So we'll first go over our vision and sort of the problem we're solving. Then we'll go over our current progress, some challenges we face, and our plans moving forward. So let's start off with what we are building. And I'll explain this using like a conceptual framework. So first we have knowledge, and then there are skills. And you learn skills by acquiring knowledge through instruction from somebody or through a course. And this is a great way to learn new skills. Once you've learned the skill though, how do you actually improve it? Here, a course may not be the best way to improve a skill as it's often time costly. Instead, one of the best ways to improve a skill is via practice. You want to practice performing the skill and then receive feedback on that practice for how to improve. This feedback often comes from someone who's an expert in that skill. And one way to think of expertise is like a learned collection of heuristics. And by heuristics, we mean like it's an approach to problem solving that employs a practical method to quickly reach a solution. So for example, a personal trainer is an expert who can identify if someone's improperly doing a curl for their body shape because that expert has knowledge on how to do a curl, but also an heuristic on how to modify that for their body shape. The problem with experts though is that they're not widely available and are costly to get feedback from. It'd be impractical to hire a professional copywriter to review every email you write. This is where a tool like Grammarly really excels. Grammarly is great because it shows us how to improve the sentence we just wrote. It gives specific feedback on your current practice of the skill. And so we want to generalize Grammarly for skills other than writing. And so our aim for Symposium Day is to build a platform where experts can go in, add their own heuristics using like a no-code interface, and then users can use them to receive auto-generated feedback on the current execution or practice of that skill.
Since the scope of this is quite large, we first narrowed this down to one domain, resume writing. Students in first and second year are always looking to improve their resume, but they don't necessarily know how to. We were actually once in their shoes. Looking back at what we did in our earlier years, we would seek out the advice of upper years that know the heuristics to use for improving one's resume. For example, instead of writing a point such as sped up our engine in first person, you should instead use third person, as in sped up the engine. Another example is to add metrics to quantitatively demonstrate the impact of your work. We are currently working to create an app where users can upload their resumes and get feedback on how to improve their structure, content, and style.
Hey, I'll be going over some of the progress we made since the start of the term. In the past few weeks, we have conducted user research by interviewing 9 students in first year. We asked them several questions to gain their perspective and test our hypotheses. We will go through a few of the hypotheses we tested. Our first hypothesis was that students don't know how to improve their resume writing. All 9 students expressed that the points on their resume could be improved, but did not know the specific actions to take in order to improve them. A few did say they would reach out to others for feedback or seek online resources such as YouTube. This confirmed that while students wanted to improve their resume, they do not know what steps to take to reach that goal. The second hypothesis was around trust. Students trusting a third-party application with their resume and students trusting the suggestions this app gave them. The first part of the hypothesis was confirmed. Students will trust the app enough to share their resume as they have already done so on personal websites, LinkedIn, or to each other for feedback. For some, they may not want to share information like phone numbers or names, and we will accommodate this by allowing users to paste their bullet points. For the second part, we found that students may be doubtful of the auto-generated suggestions. Since there is no objective measure of a suggestion, the trust is subjective. They trust upper year suggestions because of their credibility. However, all the users said they would not outright reject suggestions, and therefore we do not think the hypothesis is falsified. Instead, we will have to clearly communicate to the user where the suggestions are coming from and also use accepted/rejected analytics to improve suggestions down the road. The third hypothesis we tested was that people have heuristics on resume writing which they would be willing to share. This hypothesis was confirmed as every student had an idea of what rules they follow when writing a resume, such as XYZ format, providing metrics, displaying technologies, and keeping tense to save. People are aware of heuristics that make a better resume and are willing to share them.
So now moving forward to our actual architecture, you can see that our app's generally structured into 3 layers. So we have our React front-end client, a backend server, and then our actual core. So if you have any specific questions about like our architecture or tech stack, feel free to ask them at the end of the presentation. But one thing I'd like to point out is that we separated our backend into 2 separate services. So one is basically a middleware so that it handles all requests from the front end, and the other one has the core functionality abstracted away. And then, so this is breaking down what our core is actually doing at a high level. So coming from the client, we're getting raw unparsed text, and this is allowed to be passed into our engine through leveraging NLP libraries like Stanza. And this actually allows the text to be represented using parse trees, kind of like abstract syntax tree. And then this can be manipulated by our engine and represented as like a Nautilus doc. And this allows us to run custom heuristics and tasks on them. So based off of this representation, we can generate different feedback and suggestions and return this to the user.
So before deciding to build our MVP, we decided to design our app in Figma. And so what we planned out was to have a place where you can put in your resume points. And then on the right-hand side, we'll show you the suggestions on how you can update and fix those resume points. Now let's move on to our demo. So this is our demo. We expect users to simply just paste in their resume points in here and click Analyze. So what this is doing is it's sending the text to our NLP algorithms, and it's going to surface feedback back to the users. For example, this purple feedback shows to abbreviate the month to January or to Jan to reduce the amount of white space in your resume. Same thing for April. This green feedback is to suggest to remove the first person pronouns in your resume to make everything be in third person. And finally, this last feedback suggests to split this lengthy sentence into 2 bullet points. Notice how our NLP algorithm is able to identify the different clauses in the sentence and suggests to put which clause into which sentence. Furthermore, we have this information tab here to help users to figure out which headings you should put in the resume and in which order the headings should be in. You can give this app, you can try this app yourself on our prod URL.
Since this started this term, we encountered many challenges, and I'll be talking about 3 of them. One of the first challenges we faced since the beginning of the term was deciding on an idea to pursue. We pivoted many times for ideas. Each time we thought we had an idea to potentially pursue, the team would come together to the opportunities and weaknesses of the idea rather than jumping straight into coding. While this resulted in us starting on our current idea later than anticipated, we believe it was valuable that we took the time to examine each idea closely. It allowed all of us to understand the problem context at a greater level and discuss potential issues early on rather than a few weeks into development. This contributed to allowing us to iterate quickly in the past few weeks as we know what we want to build. Furthermore, we are all on the same page about what we want to achieve by the end of this term and by the symposium date. From a technical perspective, one challenge we faced was building the DAG executor, as it had multiple functional and non-functional requirements. Notable ones included running it entirely in memory, streaming and injecting data into child nodes, and type checking generic pipelines. Some techniques we used to overcome these challenges were implementing a custom DAG creator, executor, implementing wrappers to collect and rename parameters, and parsing function definitions to extract signatures for input and output types. Another thing was that all of us had basic or no NLP experience, which made it a challenge to understand how NLP parse trees can be used to create a heuristic. Thus, we spent a considerable amount of time researching different NLP libraries such as Stanza, Flare, and Spacey and understanding how they worked. One key issue we did not account for initially is the amount of memory NLP libraries require, which was a challenge for deployment. We originally were using Heroku for deployment, but realized the amount of memory was almost 900 MB, which exceeds the 500 MB limit of the free plan. Thus, we are currently exploring alternatives to Heroku for deploying the backend, such as DigitalOcean and GCP.
So moving forward, we have a few steps highlighted for the rest of the course, as well as going into a symposium. So our first check is now that we have our V1 infrastructure, so like the DAG and all of the heuristic definitions defined, adding just more checks so that we have more comprehensive feedback for the user. And then building upon this, so having a V2 of infrastructure, so there's a lot more features we can add for actual core infra, like having concurrency, which would allow multiple tasks and checks to run at the same time. As well as more from a user interface, we want to perform collections on user analytics, so we know how exactly the users are interacting with their product, and based off that, how we can improve, as well as doing direct UX UI testing, and based off of the responses, creating a follow-up front-end changes. And finally, just conducting more user research to actually understand from upper years what kind of heuristics we're looking for in resumes. And that's it. See you all at final demos.
All right.